Today you're going to add in the tangent parent function and we're going to work on graphing the tangent. So we're going to do the parent function in one example. As we go to create the parent function for the tangent, we want to pay attention like we did for sine and cosine. So remember, as we're choosing, what would we want to be the best x and y values for the tangent? A little side note that for sine and cosine, we chose these angles to plug into the function because the coordinates had all zeros and ones. And that made it easier to pick out values of sine and cosine. They were nice numbers that were easy for us to graph. So every time we went to one of these positions and calculated the sine or cosine, we got 0 or 1 because that's how we would just use the x and y coordinate. For tangent, remember that you have to do the y divided by the x. So we want to think about places that this would turn out really well. We're going to keep using the positions that we used before, but we also are going to want to use these 45-degree angles. I know you guys might not like the numbers rad 2 over 2, but when you divide those work out really well because they have the same number. When you divide something by itself, we get 1. Okay, so when I look at the tangents at these positions here at 0, the tangent is equal to y divided by x, which is 0. Here at 45, but we want to write it in radians, we'll use pi over 4. The tangent's going to be equal to rad 2 over 2 divided by rad 2 over 2, which is going to be 1. Here at 90, which is pi over 2, the tangent is going to be equal to 1 divided by 0. Now that's undefined, which is a little bit annoying, but we can actually mark that on our graph with a vertical asymptote. And then here at 3 pi over 4, our tangent would be equal to rad 2 over 2 divided by negative rad 2 over 2, which will be negative 1. And then here at 180 or pi, our tangent will be equal to 0 divided by negative 1, which is 0 again. If we kept going, at 5 pi over 4, our tangent would be equal to negative rad 2 over 2 divided by negative rad 2 over 2, which would be 1. Our tangent down here at 3 pi over 2 would be negative 1 divided by 0, which is undefined again. Our tangent at 7 pi over 4 would be negative 1, and then we'd be back to 0. Notice the numbers. We went 0, 1, undefined, negative 1, 0, and then notice it started repeating 1, undefined, negative 1, 0. So we actually don't need this second cycle because it's repeating the first one. So we're only going to use that distance to do our tangent, which means for tangent, we're only going to have a period of pi, and we are going to choose to use these angle locations, and we're going to write them on the chart. This was kind of messy, but it's just to show you guys why. Okay, so on this chart, we're going to start at 0, but rather than going to pi over 2, we stopped at pi over 4, then pi over 2, then 3 pi over 4, and then pi. And then here's the tangents we calculated at each of those. 0, and then 1, and then undefined, and then negative 1 and 0. So on this graph, we're going to scale it by pi over 4s. So you see it only takes half as long. The period here is only pi compared to sine and cosine. They had a period of 2 pi. Now the points we've got so far are 0, 0, pi over 4, 1, pi over 2, undefined, 3 pi over 4, negative 1, pi is 0. This is kind of a weird collection of points, but you guys also saw on Desmos what this graph kind of looks like these squiggles. So what you're seeing here is the midline, kind of right here. I'm going to erase it, but so you guys can see it, because I can see points below that and above that. And if I wanted to continue the pattern, So here's kind of the graph you get with these points. But if you need a better visual, it means one more dot over, you would go back up to here, and then you'd have the other asymptote. You got to make sure there's 3 points in between. So then you'd get those squiggles. And over here, one, we'd get this lower point, and one more, we'd get like an asymptote. And there's those squiggles. And that's 2 periods of the graph. We kind of have a weird section of it when we graph this parent function. For our amplitude of this function, it's none, always for tangents, because amplitude needs to be something where you can see the midline and you can see the tops and bottoms. And the tangent function doesn't operate like a wave, so it doesn't have that. You guys are not going to be responsible for the domain of the tangent function, and the range is all real numbers. So get down this parent function. If you have to, pause the notes, and then we are going to actually go through and do a graph of a tangent function. All right, so here's a tangent equation with a lot of parts, okay? I'm going to walk through the 2 ways of graphing this again. And this is already written with your b separate from your x minus h, so we don't really have to rewrite that equation. What I see here is that my a is 1/3, my b is -1/2, and my h is positive pi over 2. So knowing that, if I had memorized the tangent graph, I would kind of expect this from the parent function, if you're going to try and do these the same way that we did previously, and if not, that's fine too. And then I have to know in my head that when I extend this, there's going to be more to it, so I can see those 2 portions of it. Now, I want to pay attention first to the fact that b is negative, so that's going to cause a horizontal reflection. So I basically started here and drew all my points to the right. Basically now I want to mirror all those points to the left. So it would look like this. We would start here. And we're getting these points like this. Okay, and again, our continuation of that, if you need to visualize it, would be here. And then over here. So it'll kind of look like the curves go a different direction than they did before. Okay. Now, our starting point is going to be pi over 2 to the right. And our midline is going to stay at 0. Because notice there's no k value here. All right, it's like there's a 0 at the end. There's nothing extra moving this graph up or down. And then our a value is 1/3. So that just means we don't call it amplitude anymore, but we had still plotted these points from the parent function 1 unit above and 1 unit below the midline. Now we only want those to be 1/3 of a unit above and 1/3 of the unit below. So we can basically create this graph if we know the scale. Remember, if you're working this way, in order to find the scale, the first thing we would do is find the period. For sine and cosine, we always started with a period of 2 pi, but tangent is different, and tangent has a period of pi. So we're going to start with pi unless we have a horizontal stretch or compression. We do with our b value. So our b value is 1/2, which means it gets used like 2/1. And so this is going to give us 2 pi as our period. And so one way that we would get our scale is we're going to take 2 pi, since we know that's going to be like the 4th mark, we're going to divide it by 4. And so then we would see that our scale is going to work out to pi over 2. So on this graph, I would want each mark to represent pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, and then the negatives are just in the other direction. And I think we're going to be using those today because you can see the way we drew our graph after that reflection. So I'm just labeling those well as well. And then remember, our midline was here on the x-axis. But we only wanted to graph a third above and a third below. So I'm going to kind of mark -1 and 1, and then maybe split it up into thirds so I can kind of gauge for myself where to plot those points. And now I would start at pi/2 to the right, that's on the midline. And so I'm following this sequence of points, midline, and then one above for that part of the branch. And then this is the asymptote. And then this one is at a point below, and then on the midline. So I'm getting half of this curve and half of this curve. And so to finish 2 cycles of this graph, I'm going to finish each of those curves. So this one would then come down and then have an asymptote. And then you can see 1 complete cycle there. This one would go up to this point and then have an asymptote. And you can see 1 complete cycle there. Now, for those of us that aren't very comfortable with this method, we'll go back to using our table. So we'll use our parent function table from Tangent. So you have that on the sheet that we just filled it out prior. So I'm getting these values from there, and you would either have this memorized or you understood the way that we're making it so that you have a parent function to start with. And then our transformed table, so our b is -1/2, so x will be multiplied by -2, the reciprocal of b, and our h is pi/2 to the right, so we would add pi/2. Our a is 1/3, so y will be multiplied by 1/3, and we have no k. Then I'm going to take each of these x values and transform them using this little formula here. I'm going to multiply them by -2 and add pi/2. So here are the things that I would get. And then I'm going to do the same with all of these y values. I'm going to multiply them by 1/3. Undefined just stays undefined. You can't do any arithmetic with it. So as weird as that is, it's kind of nice. You guys don't have to do very much arithmetic. And then we should see these points plotted. To scale the graph here, remember that we talked about when you make this table of points, you'd want to look at the x values and you'd want to figure out how far apart any 2 of them are. So there you see 0. And so you could get pi/2 as your scale and number this the same way that we did previously. And then we should be able to see all of your points. So pi/2, 0. I'm just going to replot them in a different color so you guys can see. Pi/2, 0, 0, 1/3, -pi/2 undefined, -pi, -1/3, -3 pi/2, 0. So you get those same points that we got here. And then you guys would complete the cycles of the graph the same way that we did. The amplitude is going to be none, because again, this doesn't have the wave-like feature. You guys are not responsible for domain, and the range of this function will be all reals. For the phase shift, remember that's just your horizontal shifting, so our graph went to the right pi/2. So that should give you the parent function for tangent, and then this one example, and that should help you work on the practice. So you guys right now need to open up that skill 4 practice and try those tangent problems, and then we are going to check that when I return.